This video is to help with question number 9. So first of all, when you read the question, we know that we're talking about a ladder, and the ladder is what we're asked to find the length of. So the video that I gave you, I don't know if it was, I think it's Professor Dave Explains. He does a ladder problem that's going to be more similar to your exam. I think it's easier than this book problem, but I still think it's a good idea if you understand this book problem. So I labeled, just like Pythagorean theorem, I guess that's why I labeled that side C. That's what we're trying to find. We know that when this is 3 feet away from the base of the ladder is 3 feet away from the wall, we know that it's moving at 0.2 meters per second. And we also are given that this is dropping. And since it's going down, that's why I changed that to negative 0.15. So the rates are the derivatives. So right now we know x, x prime, and y prime, and we're trying to find c. So the first thing I did is like, well, that's too many variables. So I did the Pythagorean theorem here, and to solve for c, I have square root of x squared plus y squared, and then do you guys see I plugged in the 3 there to get the 9. So this is what c equals. Now let's find the derivative of c to then see if we can find places we can plug in our x prime and y prime. And this is probably the hardest part. So you have to do the chain rule. And since we are taking the derivative of c, you have to do an x prime and a y prime because we're not taking the derivative in terms of x's or y's. So it's kind of like you have to do implicit differentiation. Once you do that, you see that you can plug in the 0.2 and the negative 0.15. And basically, you can hopefully follow along the algebra there to finally get to where y equals 4. So once you know y equals 4, and we know this is 3 meters, if this is 4 meters, then we know the ladder is 5 meters. So I hope that helps. And again, I really encourage you more so to write down the problem from the Professor Dave video.